This is the technology that removes just over 8 degrees Celsius of heat in Saudi Arabia and provides some comfort for pilgrims who face temperatures exceeding 48 degrees Celsius. We are in the Middle East, specifically in the west of Saudi Arabia, in a small holy city of Islam called Medina. With just over 1.8 million people, this city is home to Al-Masjid an-Nabawi, which translated means the Prophet's Mosque, in this case, the Prophet Muhammad. With about 400,500 square meters, including the main building and the outer courtyards, it is currently one of the largest mosques in the world and the second holiest site in Islam, second only to the great mosque of Mecca, Al-Masjid al-Haram. During the Hajj, which is the annual pilgrimage held in the holy city of Mecca and is mandatory for every adult Muslim who has the health and means to do so, must be done there at least once in a lifetime. The Prophet's Mosque, which has a capacity for about 600,000 people, is crowded with more than 1.5 million pilgrims from all parts of the world. But that number can be much higher, reaching something around 2.2 million people. The problem is the high temperatures in the region, which, being literally in the desert, easily exceed 48 degrees Celsius at noon, with variations ranging from 45 to 54 degrees Celsius as a result of Arabia's natural climate. This extreme heat affects more than 1.5 million pilgrims who perform most of the Hajj rituals outdoors for long periods of time during the day. The 2024 Hajj, lasting about 4 days, has already turned deadly, with over 1,300 people losing their lives across Saudi Arabia. It's especially hard for the elderly and those with chronic or terminal illnesses. To mitigate part of this problem and create a minimally comfortable environment for the pilgrims, SL Rash and Sifar Architecture collaborated to improve the microclimate of the mosque. The solution they found was a forest of giant convertible umbrellas, which served to protect the faithful from the extreme heat and from the risk of getting wet and slipping on the very rare rainy days. They were designed to ensure comfort for the thousands of pilgrims who visit the site, not only during Hajj, but also on a daily basis. 250 umbrellas are installed in the mosque's outer courtyard and other areas, covering much of where the faithful gather for prayers. Each umbrella is about 25 meters tall and, when open, covers an area of 25 by 25 meters. They are made of special polytetrafluoroethylene fabrics, or polytetrafluoroethylene, also known as Teflon. It's a heat-resistant, waterproof material capable of reflecting sunlight, providing a more pleasant temperature underneath them. These high-tech sunshades withstand ultraviolet radiation, provide ideal shade, and reduce temperatures by at least 8 degrees Celsius, with some sources indicating that this reduction can reach 10 or even 12 degrees Celsius, which is really impressive. And all of this while maintaining the architectural integrity of the mosque, which is extremely important, since it is a very sacred place throughout Islam. The umbrellas are fully automated and they open and close according to the time of day, providing shade from the sun during the day and allowing the starry sky to be visible at night. The umbrellas are designed to harmonize with the imposing architecture of the mosque. In addition, the umbrellas have ventilation and water misting systems, further reducing the temperature around the worshipers. In fact, there are several requirements that these umbrellas had to meet in order to be implemented in the mosque. According to this article titled Shape, Search, and Value Engineering, in the design and construction of mechanical umbrellas for the Holy Mosque in Medina, Kingdom of Saudi Arabia, 6 engineering requirements that these umbrellas had to meet are described. They are: the material should withstand the ultraviolet rays of the intense sun for a long enough period to justify the investment. The membrane had to be made from a highly foldable material. The material should be pleasantly white and remain undamaged by burning under any conditions. Cover the whole post with white marble and treat it like the columns, adding brass capitals, air conditioning vents, and electric chandeliers. Mechanical maintenance activities should not occur in the yards, and the poles of the sunshades should be used to transport cold air from the central air conditioning ducts. Channel the rainwater through the same pipe and include some decorative lights on the pole, similar to the regular columns of the mosque. One of the big challenges was the sunshade membrane. The membrane needed to be made of a material that could fold very well. Secondly, it had to withstand the ultraviolet rays of the intense sun long enough to justify the investment. Thirdly, it had to have a nice white appearance and not suffer burn damage under any circumstances. A specialized weaver in northern Germany created a canvas from a new gore fiber made entirely of polytetrafluoroethylene, or Teflon. Teflon is known for being completely resistant to ultraviolet rays, and samples of this material have been exposed to full sun in Florida since 1950, and so far, they show no signs of deterioration. However, it was challenging to learn how to weave this material, as well as to sew it and add the necessary accessories for its suspension, among other details. Coit High-Techs assisted with developing this process. Wind tunnel tests were needed to determine the forces transferred from the membrane to the structure. Dynamic and static loads needed calculation. Tests were conducted with different types of fabric until the required strength was achieved. Finally, it was necessary to develop ornamentation that would harmonize with this new form and with Islamic architecture without interfering with the functions, but rather enhancing them. Another challenge was the folding mechanism. For the articulated folding structure of a giant umbrella with a diameter of 25 meters, it was necessary to find suitable technology. Detailed studies determined that the drive system should be hydraulic. Maintenance for mechanical objects should occur in a remote location, not the courtyards, to avoid disturbing the faithful if a malfunction occurs. Here, underground, with the remaining mechanical systems. All the pressurization equipment, such as pumps, valves, electric motors, and the control system, was allocated away from the courtyards. A value study recommended placing this infrastructure about 150 meters from the courtyards, and the project was modified according to this recommendation. In addition, the architect wanted to use the umbrella poles to transport cold air from the central air conditioning ducts, to channel rainwater through the same pipe, and to include decorative lights in the poles similar to the regular columns of the mosque. Finally, the entire pole needed to be covered with white marble and receive treatment similar to that of the columns, featuring brass capitals, air conditioning vents, and electric chandeliers. Another challenge was the covering and flanges. The importance of the location required a sunshade design that looked good both when open and when closed. It was clear from the start that a flap mechanism was needed. It was expected that the mechanism would completely close the sunshade when the membrane was folded, providing a serene and controlled appearance, instead of the typical bundle of folds commonly found in convertible structures up to that point. A value analysis study on aircraft designs led to the idea of using a flap mechanism similar to airplane rudders. This design met the project requirements and allowed a small unfolding movement of the main arms to result in a large movement of the flaps, and vice versa. Some of these mechanisms, created from scratch, were patented. In other words, what appeared to be simple umbrellas to protect people from the scorching sun and temperatures that sometimes exceed the 50 degrees Celsius mark. In fact, it hides a true masterpiece of engineering, in which dozens of airplanes and engineers from various fields made important contributions to provide shade and a bit of comfort to the millions of pilgrims who visit the Prophet's mosque.